In this video, we want to begin discussing different ways of counting, finding out how many different ways one item can happen or one outcome can happen. So we want to first start with the fundamental principle of counting. If a sequence of several operations is to be performed, the number of ways to perform the sequence is formed by multiplying together the number of ways to perform each operation. So this means we have one thing that's happening, a second thing that's happening, a third thing that's happening independent of each other. The way we look at this is lowercase k times lowercase k times lowercase k up to however many different operations we're looking at. Now I realize that that doesn't make much sense, so let's look at an example. One example is the fixed price dinner at this particular restaurant provides the following choices. It has an appetizers, super salad. It has entrees, baked chicken, broiled beef patty, baby beef liver, or roast beef. It has desserts, ice cream, or cheesecake. How many different meals can be ordered if one item from each type is chosen? So let's start with, we have our appetizer. We have either soup or we have a salad. Off of that super salad, we can have baked chicken. We can have the beef patty. We can have the baby liver. Or we can have the roast beef. Same thing, off of the salad, we can have baked chicken. We can have the beef patty. We can have the baby liver. Or we can have the roast beef. Off of each one of these, we can either have ice cream or cheesecake. 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 Now, if I were to do this for each time, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different ways or different combinations I can choose, because realize that each one of these ending with the dessert is a different selection. An easier way to look at this is we have the appetizers. We have the entrees. And then we have the desserts. There are 2 possibilities for appetizers. There are 4 different possibilities for the entrees. And there are 2 different possibilities for the desserts. We multiply these 3 together. There are 16 different meals that can be ordered. So when we're looking at this and each one is different, it has no bearing on the other one, such as it doesn't matter if I choose a soup or a salad, I can still get the baby liver. Or it doesn't matter if I choose the beef patty or the baked chicken, I can still get ice cream. These selections are independent of each other. So we can take however many of each selection there are and find out how many different meals can be ordered, or how many different outfits are in your closet. You have different color pants, different color shirts, different color shoes. You can actually figure out how many different combinations are in your closet. Another thing that we want to look at is something called permutation. The word permutation is another word for ordering. So we're going to put things in order. When we count the number of permutations, we're counting the number of different ways that a group of items can be ordered. For us to look at permutations, we first have to look at what we call a factorial. Factorial is the product of an integer and all the integers below it down to 1. So we take that integer, we multiply it by the integer just below it, then the integer below that, and we keep on going until we get 2 times 1. Let's look at an example of this. If I want to do 7 factorial, well, I start with the 7, and then I look at the number below it, 6. I look at that number below it, which is 5, and I keep going until I reach 1. I multiply all of these together, so 7 factorial is 5,040. Now the one that gives us a little bit of a hiccup or confusion is 0 factorial. 0 factorial is just 1. We've taken all of the other integers away. We're still left with the number 1. So a permutation is a way in which a set of R items is selected from N. Remember, this is my sample size. And we're going to order the R objects. The notation is N, P, R. So we have a permutation. We start out with the N number of items, and we're going to select the R number of items. The formula for this is N factorial divided by N minus R factorial. To better illustrate this, let's look at an example. In how many ways can horses in a 10-horse race finish first, second, and third? So we have a total of 10 horses, and we have 3 places that we're looking at. First, second, third means that there is an order to it. So that means it's going to be a permutation. So that's going to be 10 P 3, not R, 3. So that's going to be 10 factorial divided by 10 minus 3, that quantity factorial. When I look at this, this is 10 factorial. 10 minus 3 is 7 factorial. Okay, so if I want to, 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. 7 factorial is 7, 6, 5, 4, 3, 2, 1. Whenever we do division, the 7s divide out, the 6s divide out, the 5s, the 4s, the 3s, the 2s, and the 1s. Which leaves me with, on the numerator, 10 times 9 times 8. On the denominator, it basically leaves me with 1. So 10 times 9 is 90, times 8 is 720. The top 3 horses can finish a 10-horse race in 720 different ways. So the top 3 horses can finish a 10-horse race in 720 different ways. There is ways to do this in your calculator. There's a separate video inside the Canvas if you want to look at how to use the calculator for this. Let's look at another example. The student council at a certain school has 10 members. So that's our N. 4 members will form an executive committee consisting of a president, vice president, secretary, treasurer. So our R is 4, and this has an order because we have president, vice president, secretary, treasurer. What is the probability that Zachary is president, Yolanda is vice president, Xavier is secretary, and Walter is treasurer? This is wanting the probability. So we have to think about the probability of these 4. Well, how many ways can Zachary be president, Yolanda be vice president, Xavier be secretary, and Walter be treasurer? Well, there's only one way for all 4 of those things to happen. So that's 1. Now, how many total different ways can 4 people be selected for president, vice president, secretary, and treasurer? Well, that is going to be 10 P4, permutations. So I'm going to take 1 divided by 10 factorial over 10 minus 4 factorial. So 10 factorial over 10 minus 4 factorial. It's going to be 10 factorial over 6 factorial. Whenever I work out the 10 factorial over 6 factorial, that actually leaves me with 10 times 9 times 8 times 7. And so whenever I actually do that, it's going to leave me with 151,200. 1 divided by that value. I apologize, that's too many values there. It should be 5,040. 1 divided by 5,040, it comes out to be 0.000198413. So if I round to the 4th decimal place, that's going to be 0.0002. Very low probability. Probability: Zachary is president, Yolanda is vice president, Xavier is secretary, and Walter is treasurer is 0.0002. Now, if they were asking what's the probability that just Zachary is president and it doesn't matter who's after him, those would have a higher probability. But because we're looking at the probability of all 4 of these events happening at the same time, it's a much lower probability. So try some of the problems with counting and permutations, and then let me know if you have any questions.